Hi there, and welcome to this tutorial for motion matching for Unity. In this tutorial, we're going to take a look at how we can code an extremely simple character gameplay controller that interfaces with MXM. Now, the intention here isn't to show you exactly how to code in C#. It's not intended to create a character controller that is going to necessarily work for every game or your game. In fact, I wouldn't even code one this way. However, my hope is that the concepts that I show you of interfacing with MXM can then be used in your game, in your structure of code, in a way that will work. I want to be as simple as possible and explain why we call functions from MXM at certain times. So without further ado, let's just dive into this from scratch. I've made this script called Extremely Simple MXM Controller. Let's double click on that and we have nothing. So the first thing we need to do is we need to use MXM. That's the namespace that MXM is under so we can have access. The next thing we need, we're going to need some references to the components. So let's get those. And we're also going to want to have a reference to the trajectory generator so that we can manipulate that as well. Okay, so there are my two variables to store the references. Let's then get those with the start function. And there we have our references. Okay, so we're set up. We can now talk to MXM because we have these references. Let's do a few things that are more gameplay-like now. We've got to think about our character. Let's hypothetically create a character that can run around, can then equip a gun, so just go into a combat stance basically, and then when you aim with, let's say, right click, your character converts into a strafing mode, and you can also crouch and prone. So these are the things that we're going to hypothetically create here. So the first thing we want to do is we want to, let's create some enumerations. Now, we could think of those as a whole bunch of different states, combat, but then we have things like combat strafing, combat crouching, combat prone, and then we have normal strafing, normal. We don't want a state for every single one of those. We just want some really high level states, and we can have multiple states at once. So we could have combat active, and so we could have a stance, and then strafing on or off. So they can be separate sort of states. So let's start with strafing. Strafing on and off. You could think about strafing in any situation. You could do it while you're crouching, you could do it in combat, and you could do it out of combat. So let's just make it its own thing. I'm actually going to make that a property. We're going to need a little bit more. Let's make an enumeration. I would usually do this in a different script, but for the sake of this tutorial, we'll do it in the same one. Very simple, and let's chuck that in here. I'm going to also make this a property. We're also going to want to have an in combat or out of combat. Now that's kind of a binary thing. Okay, so we have our variables that can now define our state. Now obviously you would probably make a much more complex state machine if you were making a game. Again, this is just so that this can be quicker for a tutorial. My hope is that you will take this and understand the concept so you can use it in any way you like. So let's create our update function. Okay, so in our update function, the first thing I'm going to worry about is our stances. We're not going to look at strafing and combat just yet. Let's just look at our stances, and we're going to say, well, we can be in any one of these stances when we're either in combat or strafing. So it can be the top level of our management. I'm just going to create a switch case statement. Okay, so now we have our switch case statement, which we're using as a very rudimentary state machine. So I could just put my logic in here for each one, but I don't want it to be too messy. So let's make a whole bunch of functions for each of those states. Okay, and now we can call each of these functions within here. Okay, so now that we have those functions, we can look at them on an individual level. So when we're standing, we're going to wait for input to crouch and then crouch, or wait for input to prone and then prone. Now keep in mind that your general locomotion, like moving around, is handled pretty much automatically. So we're not going to worry about that at all. We just don't do anything unless we're changing the state of our character. So with our update standing, we want to poll for a key if. Now, you could be using the new input system, that's fine. That's not really part of MXM, it doesn't matter. You can convert this to your own input system however you like. I'm just using the old input system as an example because it's actually still the current one at the time of making this video. Okay, so in this case we want to go to crouching. In this case we want to go to prone. Alright, so we want to have a similar thing in each of these. So when we're crouching, if we press X, we go to prone. If we press left control, we actually want to go back to standing. It's like a toggle. And in the case of this one, if we're prone, let's say if we press left control, we go to crouching. And if we press X, we go back to standing from prone. Okay. So we've set up the basic skeleton. Let's now tell MXM, hey, I want to change to crouching. Now, MXM uses a tagging system. If you haven't watched the tagging tutorial for required tags specifically, please go watch this. You won't understand it otherwise. However, basically what we have is similar to Mechanim, how we can set a Boolean parameter. In this case, we're just telling the system, hey, I require animations with this tag. Because of course we don't have transition logic. It's not a state machine. So we just have to say, hey, only play animations with a specific tag. So go to crouching. So in our MXM preprocessor asset, we set up a crouch tag and we tagged animations with it. This is all hypothetical, of course. I'm not going to actually do that. This is how we would tell the system, hey, I need a crouch tag. So that's when we're standing, we go to crouch, and same thing when we go to prone, except we're just going to pass in the name of the prone tag. Okay, so that is that. So let's do the same thing with crouch. When we are crouching though, we're not just going to add a standing tag. In fact, there is no standing tag because standing is the default state. So it's actually just no tag. So in this case, we want to just remove the crouching tag. .remove required tag. And we will remove the crouch. And if we're going to go to prone, we're also going to remove the required tag, but then we're going to add the prone tag. Because the tags, you can have multiple tags active at once, and if you don't remove one, it's just going to stay there if you add another one. So we're not crouching anymore. If we failed to remove this crouch tag, the system would look for an animation with both crouching and prone, which doesn't really make sense. So you've got to keep track of your tags. So when we update prone and we hit left control, we're going to remove, so I'm just going to copy this, we're going to remove the prone tag, and in fact, in both of these cases, we're going to remove the prone tag. So remove the prone tag and go straight to standing, we don't need to do anything else, but here, when we're going to crouching, we need to add a required tag of crouch. So now already we've set up a system where we can play our game, assuming we've set up our animations correctly and tagged them correctly as per previous tutorials. Now this logic will allow us to go between crouching, proning, and standing by hitting left control and X in all those individual states. Next, let's go a little bit further and then add strafing to that. Okay, so our strafing is a little bit differently. It's just a Boolean, and in our case, we're going to say that within any of these stances, we can turn strafing on and off. We could strafe while we're crouching, standing, or prone. So it can actually live outside of the switch case statement as a separate thing. And let's, so maybe when we right click to aim or something like that, it'll, when we're holding down the right click, it will so when we push the mouse down, we're going to add a required tag. Actually, no, I'm going to do it a bit more than this. I'm going to call a function. So we've got our updates for these. I'm going to call, and it might seem overkill at this point, but you might see it a little bit later. So if I am holding down, so I'm going to make strafing equals true. And I'm going to say begin strafing. And in this case, I'm going to say strafing equals false. And and end strafing. Okay, so we can leave it as simple as that in our update function. I just don't want to clog up the update function too much. Go down to these ones. So begin strafing, there's a few things you need to do. So when we start strafing, we need to change the MXM trajectory generator mode to strafing equals true. And we'll do the opposite. When we end strafing, we set the trajectory generator strafing mode to false, because when we're strafing, the trajectory needs to be different. Specifically, the facing angles need to be the way the character is facing in a strafe rather than following their nose. So it's false. Next thing we're going to do in this case, look, it's possible to do strafing by simply matching the trajectory. However, if you really want it to behave 100% perfectly and be guaranteed, you're going to also want to have a strafing tag. Now, again, if you do it really well, yes, you don't need this. But if you're lacking animations, which is probably going to be the case with strafing, you're probably not going to have enough transitions. You're going to want to be very explicit. So you tag up your strafing animations with an additional tag in addition to your stances. And I'm going to say we add required tag strafe. And we'll also do the same thing, except we're going to remove the required tag for strafing. Now there's a few other things you might want to do for strafing if you're using angular error warping, which you probably should be. In general, you're going to want to change its mode as well. So let's change that on the MXM animator. So angular error warp method equals, and we want to change it to trajectory facing. So this is the one that we use with strafing. So with trajectory error warping, when we're just following our nose, we generally use current heading. However, we want to use the facing angle of the trajectory points to define the strafing and to define the warping. If you don't know what angular error warping is, then please go and watch that tutorial. I've already done it. It goes into it in depth. So we're going to change that as well. So begin strafing, and then when we end strafing, we're going to turn it back onto the current heading. So what's actually happening here? There's two different types of ways we interface with MXM. One is on its public interface, and one is in its internal interface. So what I mean by public interface, if we find a character here, one thing that we do is we're literally changing these options on the inspector at runtime. So the trajectory, so this angular error warping change that we've done is like a front-facing change. We're simply changing the settings on the inspector, except we're doing it through code. So if we see here, here's the current heading, we change it to trajectory facing. However, the tag system is internal because there's no way to really set it here, and that wouldn't make sense. So that's like an internal API. So there's two things you're going to be doing. Every single one of these settings can be changed on here at runtime. You can look that up in the documentation for every single one. So when I change to strafing, I could change the warp rate, the distance threshold, the angle threshold, and I might do that later once we refine this a bit more. But for now, just changing that is enough. When I changed the trajectory, MXM trajectory generator to strafing mode, all I did was tick this box and uncheck it through code. It's actually really simple. This strafe one through code, not flattened trajectory. It's super simple. It's just we're doing it through code now, which means we can do it at runtime. So that's the basics of it. We could change the rate of warping. Actually, let's just do that for now. Let's change the rate of warping, angular error warp rate. I want to make it higher for strafing because I want it to really, because I'm aiming, I want it to be really quick. So I'm going to say 360 degrees per second. So it's gonna appear instant. And then when I end strafing, let's put it back down to what's the default here for just as an example. I'm not actually going to attach this to the character. 90 degrees per second. I'm also going to change the threshold to be much higher. let's just say 360, because I wanted to do that warp no matter what angle it's in. Again, if you don't understand this, you need to go and watch the angular error warping tutorial for more details. And I'll change this back to 135 here. Okay, so you would never actually do this, right? You would never hard code these values. I'm just showing you this as an example. In a proper game, you always want to cache these values somewhere or make them editable in the editor, and that is how it's done in the standalone demo. So please go check that out if you want a different way. Hard coding values is always bad. Just so that you are, I hope you're all aware of that. Okay, so we've got begin strafing, end strafing. We could even encapsulate this strafing in an update strafing function, but let's leave that for now. Okay, so let's move on to some other stuff. Let's move on to combat. Initial setup of combat is going to be pretty much the same as strafing because it's a binary sort of mode. And I'm going to set up two functions down the bottom here. I'm also going to add in an update combat. So once those are in, we are just going to go up here. So if we're in combat, we're going to first of all update combat. And we're also going to poll for the keys. So when we press tab, we're going to go out of combat. And no, we can actually end combat here. And instead of saying combat equals true, and same with these strafing ones, I could just chuck it in the begin strafing function. So begin strafing, I'll actually do that now. So we'll go back up here and put that in, encapsulate them next. Obviously they don't need to be separate. So strafing is false. And begin combat, we'll go combat equals true. And end combat, combat equals false. Let me check back up here. We've got end combat, and we've got the opposite. If we're not in combat, we will begin combat. Alright, so we're set up in our main update function. Now we just got to fill in some details in here. Begin combat, we'll get a tag, and we'll remove the tag in end combat. And my combat logic here. So in here, this is where you would do your, like, if the mouse button is pressed. Let's just do it. Shoot bullets, and I'm not going to actually do a function for that. This is hypothetical. You would put your whatever shoots bullets there. Okay, that's as far as I'm going to go with combat. Obviously, you could do extra things like have layers for playing and equipping and unequipping animation. And you could do that by using MXM's layer system, but I'm not going to go into that in this tutorial. You can look it up in the documentation or wait for the specific tutorial on that. You can use upper body masks for that, or you could even use the Mechanim animation controller and mask the upper body and do it that way. There's so many possible ways to do this stuff that I can only point you in the general direction. You have to decide which way you want to actually do that. But we've got the basic setup. We can now strafe. We can strafe in combat. We can run around normally in combat. We can be crouching and prone or standing in combat and out of combat. So we've got all of these different things going together. And all we've really been doing, the biggest thing we had to do was change a lot of stuff for strafing to work properly. But otherwise, all we're doing is adding and removing tags. This is the bread and butter of motion matching for, I guess, your general locomotion. We haven't done any events, so like any attacks or anything. I suppose for a shooter, shooting the gun, you'd probably do an upper body animation for that. You wouldn't do an event, but we might do a jump event soon. But there's one thing that I really need to talk about with locomotion, and that is the speed of your character. Let's go here and let's just play the demo, and I want to show you something important. So here we have our character, and we can see that, oh, I'm in the strafe mode because I haven't changed that. I changed it while I was showing something in the example. Let's put the strafing, strafe mode off. Okay, cool. Okay, so we can see that the green trajectory has a specific length. The length of that trajectory is based on the speed of the character. Here I've set it to 6.2. Now, there's two aspects to this. What if our combat movement is slower? What if our crouching movement is slower? So you're actually going to have to change this max speed at runtime based on your logic. That's something important. So if I reduce this to 3, this max speed, my trajectory is only ever going to get to max speed. Obviously it doesn't work with this character because it doesn't have any animations that run at that speed. And you can see why it's so important, looking there, that I have the correct speed. The other aspect is input shaping. Obviously if you're using a joystick, you're going to be able to push that joystick to values anywhere between 0 and 1. It's not as on and off like a keyboard. So to achieve this in a lot of games, in fact not even just motion matching, you need to remap those inputs to viable input ranges. Now the MXM trajectory generator comes with something called an MXM input profile, which is an asset that you can create through create MXM utility input profile. Now I'm not going to go into detail over that. Basically it's a number of values that remaps your input to a viable input that you choose for your system. Those viable inputs are input magnitudes are the speeds at which your animations go, or the proportion of the max speed which we set up here. If you don't understand that, don't worry. There's going to be a dedicated tutorial to MXM input profiles. But just note that this is changeable at runtime. So is all these speeds and position bias, which is basically responsiveness, and direction bias, directional responsiveness. So all of these can be changed at runtime, and that is how we need to control the speed. So let's say in our example that, let's say hypothetically our combat and normal locomotion is the same speed. There's not much difference there. However, let's say that our crouching and prone are different speeds. So let's go back and revisit our crouching and prone. And we've got these updates. And when we're in standing, we've just requested a crouch tag, but we haven't changed the speed. Let's say hypothetically we run at half the speed of our character. So we would have to tell the MXM trajectory generator that our max speed has now changed. So .set .max speed, and I'm going to say it's 3.1, which was half of what we had for the running. When we're prone, I'm going to say that's half again, more or less. MXM trajectory generator .max speed. Now you could change the responsiveness as well if your animations are less responsive at slower speeds. It just depends on how you do it. You can change all those values at runtime. So let's just say that's 1.5. And we do the same thing. So when we're going to crouch, we could do what we did with strafing, and we could have a begin crouch, begin prone, begin all that. And that's probably, you would do something like that. You would at least have that in a state machine, but I'm just going to hack this in so we get the idea. So when we're going to crouch, you want to change the speed to that. When we're going to prone, change the speed to that. Oh no, sorry, this is not going to crouch, this is going to standing, so I'll change it to 6.2 again. Hypothetically, this is the speed of my character. It might not be the speed of your character, keep that in mind. So we're going to crouch in this case, so we'll set the speed to that, and we'll set the speed to this. So that'll change the length of that trajectory so it'll match your thing. The MXM input profile is another thing on top of that. Again, it just remaps your inputs so that you can only have viable inputs. But yeah, there will be a tutorial for that. So we can manipulate the speed, we can manipulate everything on the trajectory generator script, and we can manipulate everything on the MXM animator script. We can add tags and required tags. Okay, so before we finish, let's do one really quick thing. Let's add a jump event. Okay, so the first thing we're going to need to do for our jump is we're going to need a reference to a event definition that we create in the inspector. So we go private MXM event definition and jump definition. Okay, so this holds all the data about our jump event. Now, if you haven't watched the events tutorial, you must go and watch that to understand this. I'm not going to go through that again. I will, however, say that to create an event profile, we right-click, create, MXM, core modules, event definition, and we get this script. And it allows us to set up a whole bunch of data so that when we want to call an event, we don't have to have a massive function that has all this information. We just pass this asset. So I'm just going to delete that, and we'll go back here. So we would slot this into our, we actually need to serialize this. So you could either make it public or put serialize on top of it. And we would slot that into our inspector for this script. And then at runtime, what we do is when we're update standing, we say if input.getKey, we will go mxm animator.begin event, and we can pass in that jump definition. And that's all we need to do. Obviously, this can be way more complex. The event system is very in-depth. It has a lot of functionality. This is just really simple. So we can now strafe, we can crouch, stand, prone, we can go into combat, and we can do a jump, or it might be an attack with a sword or something, whatever. Events can be used for a lot of different things. Now, yeah, as I said, I'm not going to go into upper body layered animation. I feel like though that requires a dedicated tutorial to really teach that. But here it is. This is a very extremely naive setup. But the point is not to show you how to code. It's to show you what functions you can call in certain situations. You can now place this in your own state machine system or your own gameplay system. I highly recommend, especially if you are new to programming, try something like Node Canvas. Try something that has a visual state machine where you can just sort of code the little nodes or something like that, and it'll just run it, and you can string together the logic. But any way you want to set this up, it doesn't matter, as long as you are using these functions to tell MXM what to do. In that way, it is no different from Mechanim or any other animation system. All you're doing is telling it what to do and changing some settings. That's all there is to it. So I thank you all for watching. I hope this has at least been helpful to just get an idea of how you would construct a character. Again, it's not the best character in the world, but it should get you started. Also, stay tuned for more tutorials. There will be many more that are going in depth into each of these individual things. So I will see you in the next one. Have a good one.